Okay. So, I just got to wait for a second. No, I guess I don't. So, we're going to talk about a couple of things. First and foremost, when we talk about delta, right? Well, this little thing right here is delta. Okay. Now delta is it's the Greek letter for D. Your capital D in our alphabet is based on that. But delta just means change. So if I say delta T, that means change in time. If I say delta X, that means change in position. If I say delta V, that means change in velocity. So whenever you see this triangle, we're referring to change. Now we've talked about speed, but now we're going to dive into velocity and acceleration. Remember that speed is just a magnitude, right? And that everything else is a vector. So speed is 30 miles an hour. Velocity is 30 miles an hour due north, 30 miles an hour east. It has direction and a magnitude, okay? So then velocity, in a weird way, I got to get this, there we go. That's what I wanted. Velocity is different than speed. Speed is the distance per unit time, but velocity is actually displacement over time. Okay? So your textbook kind of thinks of velocity as speed, and we'll talk about that later. If you were in my AP Physics class, we would definitely make a distinction between the two. So you guys probably need to write this formula down, and the unit is meters per second, right? So everything we're going to do, not everything, some of our homework assignments we don't do meters per second, but when we do a lab, I'm going to insist that you guys do meters per second, okay? So velocity is the change in distance over the change in time. And since we're measuring our distance in meters in a physics class, and our time in seconds, the unit is going to be meters per second. So we'll do some conversions there sometimes. Okay, it depends on what we're doing. And so then acceleration, I'm going to scroll down just a little bit. Acceleration is a change in velocity over time. Okay? It's a change in velocity over time. Now, the interesting thing about that is that it is meters per second per second. And normally we would just write that as meters per second. So you could just think of this as like meters per second squared. But that's why we're taking a unit of meters per second and then we're comparing that as it changes over time. Okay? So our worksheet today, we're going to be doing acceleration. So it's basically the same thing we did before when we were talking about velocity, right? So last time we were talking about speed and velocity, trying to figure out the per unit rate. You travel 200 kilometers in 4 hours. What is your velocity or speed on average? And then we did the formula. But this is basically the same thing, except now we're going to say that your velocity went from 20 miles an hour to 30 miles per hour in 10 seconds. What's your acceleration? Okay? And I know what you're wondering. What's behind this little box? I don't know. Let's see. So now if we want to get real fancy, acceleration is actually the final velocity minus the initial velocity. So no matter what formula you put in, whenever I say, and write this down in your notes too, delta x is x final minus x initial. Sometimes we'll do it like x minus x0. Same thing with delta t. It's going to be the final time minus the initial time. Delta v is going to be the initial or the final velocity minus the initial. And so it's whatever delta smiley face is. It's going to be the final smiley face minus the initial. So we're going to be measuring things, and when we measure them, the change, you always go with the final minus the initial, okay? And so my favorite topic, rockets. SpaceX makes history. So I'm gonna play this little YouTube video for you guys. I think maybe if I can get it on the screen here. I'm probably gonna screw up my. And here's the kilometers per hour right here. So now what does that have to do with all this stuff? Well, basically when the rocket is landing, and we'll just put this in here on the side as a side note. When that rocket is landing, its velocity is going this way. But in order to slow down and basically stop just before it hits the ground, the acceleration has to go in the opposite direction. So if you watch that video, on the bottom of the rocket, the thrusters are going, and that is accelerating it up. But the velocity is down. There's also another acceleration that we don't talk about, which is due to gravity of Earth. So you have one acceleration causing the velocity to go down, and then the acceleration of the thrusters trying to overcome the acceleration due to gravity. And these are all changes in velocity. So what are we trying to do? Well, what we're trying to do is you're going to have a velocity up here. We'll call this the initial velocity, right? And then just before it hits the ground, our ideal final velocity, we would want that to be 0 meters per second. We just want it to barely touch the ground. So as that rocket comes down and it lands in the ocean, we would like for that velocity. Well, how do we do that? Well, we have to have an acceleration due to the thrusters that force it up. Okay, can somebody get that? So for acceleration, the basic way to do it is just A equals, and you already have these formulas written down, equals delta V over T. That's just a change in velocity over T. And it's meters per second squared. Okay. And that's it. And then the deluxe is where we calculate those two velocity. So if I worked for SpaceX and I wanted to figure out what this acceleration needed to be, I would calculate whatever the initial velocity is as it enters Earth's atmosphere, and then I would try to set this. So like, I don't know what this is. Let's say this is like, I don't know, 300 kilometers per hour. And I would convert that to meters per second. And then my final velocity I would want to be 0. Okay, and I would have to do the math on that and then the time it takes. Let's say it takes 2 minutes, so we'll say 120 seconds. That'll give me the acceleration. I can go backwards from there, use that acceleration, and then figure out the thrusters. And if I create that acceleration in the upward direction, that's all I need to do. It's a little more complicated than that, but that's basically what they do. Okay? Any questions so far? So now let's look at this. If I free fall is, you should be writing this down. Free fall, downward movement with only the force of gravity pulling the object down. So if I have an object in my hands and I let go of it at I'll leave it up there. But at 0 seconds, my velocity, the instant I let go of that little ball, it's going to be 0 meters per second. After 1 second, my velocity will be about 10 meters per second. After 2 seconds, my velocity will be about 20 meters per second. After 3 seconds, my velocity will be about 30 meters per second. Okay? Notice that the ball is moving faster and faster. So to go from here to here in 1 second, it only travels this far, about 10 meters. And from the first second to the second second, it travels 20 meters because it's only 1 second that goes, right? That passes between second 1 and second 2. And then on the third second, it travels 30 meters per second. So the distance now, because it's moving faster, it travels faster. So the displacement is greater, 3 times greater than the first second, right? So then what, if you were to guess, at 4 seconds, what do you think the velocity would be if you followed the pattern? 40. Good, thanks. So that's what we're going to try to figure out, okay? So how do we figure that out? Well, the acceleration is just going to be 10 meters per second. So from here to here, I increase, I go from 0 to 10. From here to here, I go from 0 to 10. In other words, I'm increasing by 10 meters per second squared. From here to here, it's plus 10. From here to here, it's plus 10, and so on and so forth. Whoops. Oh my goodness. This thing's got a mind of its own. So if I were to do the math on that, my acceleration is equal to the final velocity. So we'll say v minus v naught. This is another way to write it. Over t minus t naught. So if I pick these two here, my final velocity would be 30 minus the initial, which would be 20, right? Because this is the final, this is the initial. All over 3 minus 2. Well, if you do the math on that, that's 10 meters per second squared, right? Because this is meters per second, and then this one down here is seconds. So it's 10 meters per second squared. Okay? There's some videos there. We're not going to watch those today. I'll post these notes and then you can look at them. Does everybody have this written down? Yeah? So this is what we're going to do on our worksheet, is this stuff right here. All right, let's go to the next one. So a ball falls for about 40 seconds, and you guys set, and by the way, this is a possible test question. What answer is the right answer, do you think? D. Yeah, it's going to be D. Because it increases by 10 meters per second every time. Actually, the acceleration due to gravity, we call it G, is actually 9.8 meters per second squared. That's the acceleration due to gravity. Write this down. You don't have to write the question down, just write down what I'm doing in blue. Acceleration due to gravity. Now some textbooks just round that up to 10. It's a little easier. 9.8 is a little more accurate. By the way, when you got a good drop on the t-shirt drop, what was that acceleration? It was about 10, right? How many of you guys, when you were doing the t-shirt drop, if you got a good drop, you get around 10 for your accelerations? That's what you're supposed to get, right? That's how it is. Can I move on to the next slide? All right. Whoa, this is a whole bunch of stuff. We'll just crank through it, though. These are possible test homework questions. I'm going to explain it. You probably should write this down in your notes. So a car changes speed from 0 to 2 meters per second in 1 second. So what's the acceleration? Well, the acceleration, remember the formula is A equals V, delta V over T. Actually, technically, we could call that delta T too if we wanted to. So then we have 2 meters per second per 1 second, or 2 meters per second squared. Okay? And since these are like homework or test questions, you might want to write them down, right? That way you get familiar with it. For the second one, it says a bottle rocket changes from 0 to 130 seconds, or I'm sorry, 130 meters per second in 2 seconds. So what's the acceleration? Well, remember the acceleration is delta V over T, or 130 meters per second over 2 seconds. That gives you 65 meters per second, because 130 divided by 2 gives you 65 meters per second. We'll do one more. So car begins to pass on the highway. It changes its speed from 30 to 40 meters per second in 10 seconds. And then it says, what is the acceleration? So same thing here. Did you guys get 1 meter per second squared? Because you're going to say, what's 40 minus 30? 10. How long does it take to do it? 10. So it's 10 meters per second is the difference, the change in velocity in 10 seconds. So 10 over 10 is just 1. Okay. I'll try to get all that on there so you guys can write it down. So those are 3 examples. So this is essentially that little worksheet that I've given you. Basically, you're going to do this for most of those problems. Okay? Now, you can write out the larger formula if you want, but you're just going to subtract the final from the initial. So think of it like this. This is the final velocity. This is the final velocity, and this is the initial velocity. And you'll see that written 2 ways. You could see it as v sub f and v sub I for final and initial, or sometimes it's just v and v naught. So, for example, this would be v, and this would be v naught, depending on the notation. Some textbooks like to use this one. Some textbooks like to use this one. V final, V initial. And so if you were to do 130 minus 0, that's where this number comes from. Over here, this would be 40 minus 30. That's where this number comes from. Okay. Can I move on to the next slide? Does everybody have this written down? All right, cool. Speed and acceleration assignment. All right, so if you guys were to guess, here we know what the velocity is. We're going to try to find the velocity. So the velocity here is 0 meters per second as soon as you let go of that ball. We know that the acceleration due to gravity is about 10 or 9.8 meters per second in the negative direction. So we'll just round that up and say that the acceleration is 10 meters per second squared. So here, this would be 10 meters per second. This would be 10 meters per second. And it tells us right here. Over here, it's going to be 20 meters per second. I almost wonder if this is supposed to be over here. What do you think it'll be at 6 seconds? Yeah. So at t equals 6, my velocity will equal 60 meters per second. That's in free fall. Roughly. These are approximations. You got air resistance depending on the object and all that stuff. So. All right. Can I go to the next slide? Or do I need to wait for a second? All right. So this is your actual homework assignment. I'm just going to do 1 or 2 of these. And we'll go from there, okay? So let me erase this. So the first thing I got to do is, it says, what is your average speed? Well, remember that your average speed, oh wait, this is the homework. No, it's different. So the average speed is the change in position over the change in time, right? What is the average speed? So from here to here, it goes 120 meters. And then it stays at this, so it goes 0 meters. And then it goes from 120 to 180 in 40 seconds. So it ends up going a total of 180 meters total, right? So if I were to do the math on that, that would be 180 meters minus 0. Because this is the initial position of 0, and then this is the final. So this would be like x final, and then x initial would be 0. So this whole thing becomes 180 meters. Well, how long does it take? Well, it's 3 seconds here, then another 3 seconds here, that's 6 seconds, and then 4 seconds. So that's 10 seconds. I don't know if you guys realize this, but this is the exact same problem that was on the other worksheet we did. So my average speed or velocity, remember this is v bar, is going to be 18 meters per second. So now we're going to do wage again, but we're going to do a raise. So a person works for starts at $9 per hour. After 1 year, their wage goes up 50 cents. What's the raise? Okay, so the raise would be the change in pay over the change in time. So what's the change? Well, it went from $9.50 or from $9 to $9.50. So this is your final, this is your initial. How long did it take to do that? 1 year. What's the final answer? 50 cents a year. And we'll probably put some dollar signs here. So it would be $0.50 per year. Okay? Now I'll probably do number 3 and then I'll let you do the rest. So a ball falls for 5 seconds. What's the ball speed? No work necessary. So if the speed increases 10 meters per second for 5 seconds, what's the speed? Go. 50. 50 meters per second. Okay? Ashley's car is traveling at 80 kilometers per hour. How long does it take her to go 80 kilometers? It's right from your homework. 1 hour. Good. All right, so I'm going to stop right there. I'm going to let you guys do the rest of this, and then we'll come back, okay?